In today's video, we're going to go over page 1 of Unit 3 notes. And a very important part of pre-calculus is working with different types of story problem situations where we learn to write out rules for a written situation. So we're going to do that today on this first page. So let's look at number 1. We have a rectangle, has a base a base B and a height h, and has a perimeter of 38 feet. And we want to determine what the area of the rectangle is. So I have 3 different scenarios here. First of all, if the base is 12 feet long, we want to find what the area of the rectangle is. If the base is 14 feet long, we want to find out what the area of the rectangle is. And then we want to make a generalization so that we could apply this to any type of setting for any length of a base. Now, any type of a geometric setting, I would always start with a sketch. So we know we have a rectangle. And again, we know that I have earmarked the base as being B and the height as being h. We also know this little tidbit of information that the perimeter is equal to 38 feet. So we know in general, regardless of whether I do part A or part B or part C, this is always holding true, that the perimeter is always 38 feet. And now we think about what does that mean in the context of this setting. That's going to mean that 2 of the B's plus 2 of the H's will add up to 38 feet. So that will hold true for this rectangle regardless of how long we let this base be. Now, another real nice thing to see from this relationship, that if we know that a rectangle has 4 right angles and it has opposite side being the same length, we know that if 2b plus 2h is equal to 38 feet, that would also mean, dividing everything by 2, that the base plus the height has to add up to 19 feet. So if I have the setting here that if I let this specific case of the base being 12 feet long, if I let this be 12 feet, we actually know that because b plus h has to add up to 19 feet for the perimeter totally to add up to 38 feet, that this would have to be 7 feet long. So we know how to find the area. We take the base times the height, and we know that will be 12 feet times the 7 feet. And so we know that if we have the base of this specific rectangle being 12 feet, that we know that the area will be 84 square feet. On the other hand, if we let the rectangle be longer and then not quite as high, if the base is 14 feet long, we know that the perimeter is maintaining a 38 feet all the way around perimeter, and also that the base plus the height will equal half of the perimeter, or 19 feet. We would know that this height would have to be 14 plus 5 feet. Will add up to the 19 feet. So we would know here that our area would have to equal the product of 14 feet times 5 feet, which is 70 square feet. So we can see that for this specific example, if we have a rectangle and we're maintaining a perimeter of 38 feet, and then figuring out what the area of the corresponding rectangle will be, that it doesn't always stay the same. Although, in both cases, the perimeter is both of these have a perimeter of 38 feet. But the area is higher with 84 square feet in this example than this. So we'll actually even look at where would the maximum area be here in a second. So let's generalize. Now in part C, I'm not giving you a specific length for the base. I'm just saying in general, if you have a rectangle and we know that the base is B and it has a height of h, and we know that the perimeter is 38 feet, we want to write a general rule that will find the area as a function of the base. Now, if I allowed you to use both B and H, we would just say B times H is the area. However, we can't use this H. So we know that area in general for a rectangle is base times height, but we can't use this H in our formula. Our only variable that we can input is the letter B. And we know there is a relationship between B and H. As this gets longer, this has to get shorter. Therefore, we know the sum of the two variables has to equal 19 feet. Now, up here in my area formula, I want to take base times, and I want the height right there, but I can't use an h here. Again, I have to use what h is equal to in terms of b. So if I solve for h here, h is equal to 19 feet less b. And we know that's what we did in the numerical examples up here and here, that if I take 19 feet minus 12 feet, we got 7 feet. If I take 19 feet minus 14 feet, we got 5 feet. And so regardless of what I plug in for b, this is what the height will be. Now I could also distribute this through, and I'm going to put the b squared term in the front, and this gives me negative b squared, and then plus 19 feet times b. So there's another way to write the function. And we can see that in general that this would graph a parabola. And so let's do a little more analysis of this. So I can also ask you what the domain of my function is and what the range is. And so my domain, if I look at this function and I look at the side b, knowing that the perimeter has to be 38 feet, or that the sum of these two has to be half of that, 19 feet, I know that I can't let the base be 0. I know it has to be larger than 0, and I also, the sum of the two has to be 19, and I can't let the base be as high as 19 because then I won't have a rectangle anymore. So I know that my base can be any length from 0 to 19. Now, what about my range? My range on this function is what the area can be. It's a quadratic. I can see it has a negative lead coefficient, which means it bowls downward. I know I can't plug 0 in. If I could, I would have an area of 0. So here's my b-axis, and let's say I call the output c, and I call that the c-axis. So my range would be written in terms of the variable c. And I know I can't have an area of 0, but I can get really close to an area of 0. If I let this b value be either very small and very, very close to 0, I can have this be very small distance here, and it will be very, very tall, that the sum of the two will add up to 19. And if I multiply a very, very small number times a very large number, I'll still get very, very close to 0. Also, over here at 19, I know that I can't plug in 19, but that will be a 0 to my function. If I plug 0 in for b and plug in 19 feet in place of b, those two would be the places where this graph would cross the axis, if they're numbers I could use. The parabola is symmetrical, and it will do something like this. So if I want to determine what the range is, I know that there are only certain areas that can be spit out. I know when I plugged in 12 feet for b, I got 84 square feet. I know that's a possibility. I suspect that it probably goes higher than that, but I know that 84 square feet is a possibility for my area, as is 70 square feet. And then notice that this is at the vertex. And since this point is at the vertex, I really would like to know that. And I can see from the geometry of this that at 9.5 feet, that's where I would have my vertex, or that's where I would have the maximum amount of area. So if I input 9.5 feet into here, I can find out what this area will be. And so on my calculator, I'm taking 9.5 times 19 feet minus 9.5, and I'm getting 90.25. This point right here, the vertex, is at 9.5 feet and 90.25 square feet. So there's my range. Okay, so in that situation, all of the values that lie on this parabola are values that will be part of my function, and my domain of the things I can plug in anyway for b are numbers that are between 0 and 19, and the type of areas that I can get are numbers that are bigger than 0 but less than or equal to 90.25. And having the shape of this being a square of 9.5 by 9.5 feet is actually going to maximize what this area is for that specific situation. Okay, so we've looked at area of rectangles, we've looked at perimeter, we've looked at trying to write relationships between them, and kind of reviewed what we did in Chapter 2 with dealing with parabolas bowling downward and having the vertex be a place that would be at a maximum for our function. So now let's look at number 2. Now we're looking at a triangular setting. Triangular setting, I have a right triangle, so I'm going to draw it. And it has a base of B, has a height of H. And now we're letting the area is staying at a constant. This is not changing. We know this area of this triangle is 120 square feet. So I know that the area of a triangle is 1/2 the base times the height, and we're going to keep it at a constant of 120 square inches. I think I said square feet before, but square inches. And we want to end up determining what the perimeter is. So we want to end up, what is the perimeter of this triangle? And so we can see if we're going to find the perimeter of this triangle, we need to add up all three sides. And in setting A, I'm saying let's do it with this specific situation where this is 12 inches. Well, if this side is 12 inches, I know I can figure out how long this side is by utilizing this area formula. So I'll go up here. And then this will divide into there. If I divide both sides by 6 inches, I'll end up finding out that the height is equal to 120 square inches divided by 6 inches, which will give me 20 inches. So if I have a triangle that has 120 square inches for its area, and if I let the base be 12 inches long, I know the height has to be 20 inches high. Now, I know this length. Now I got to find this. It's the hypotenuse of a right triangle, so I'd use my Pythagorean theorem. And so I know that 12 inches squared plus the 20 inches squared has to equal that hypotenuse squared. And when all is said and done, I get z squared is equal to, oops, already putting that square root symbol in there, is equal to, doing the arithmetic on this, I get 544 square inches. And so z is equal to the square root of that. And notice when I square root this, I really get plus or minus, but I'm not going to deal with the negative value that would come from the square rooting and solving for this equation because I have z as a length. And I'm going to get a decimal approximation for that 544, and that comes out to be about 23.3. And when I square root the number, I get 23.3-ish, and square root the inches squared, and I get inches. Now I'm ready to add my three lengths together. I know that the 12 inches plus the 20 inches plus the hypotenuse will add up, those three dimensions will add up and give me my perimeter. And when I do that, I get about 55.3 inches. Now we're going to generalize it, because we need to be able to do it with specific settings, but also as a generalization. So now we're not going to have the base be 12 inches. It's just going to be some value b. Now the thing that will hold constant here is we know that the area of this triangle is always 120 square inches. Now the perimeter will vary depending on how long I let b be. If b is 12 inches long, we know we get a perimeter of 55.3 inches. If I make this longer, then this value will become shorter, and then the sum of the base plus the height plus the hypotenuse will change, and it won't always stay 53.3 inches. So here are my three little variables, and I know, in effect, I want to find the perimeter, which is going to look like b plus h plus z, but I have a little problem. The perimeter can only be written in terms of the function b. I can't use these. So my perimeter has to be in terms of just the letter b. So I have to figure out how long h is in terms of b, and how long z is in terms of only b. Well, we do it exactly the same way we did the evaluation up above. We know this relationship holds true. So we know that if 1/2 of the base times the height, which we're not going to give a number value for this b anymore, is equal to 120 square inches. That's the relationship between these two sides. Solve for h, multiply both sides by 2, and then divide by b, and I get 240 square inches divided by b is how long h is. Okay, always. And if I went back up here and plugged 12 inches in here, for the specific setting up here, we found out that the height was h, but this is the generalization for how long h is. So, recognize so far, I know that my perimeter is this length, b, plus this length h, which is really, in terms of b, 240 square inches divided by b, plus now I have to figure out how long z is. And I know z is related to these two dimensions with Pythagorean theorem. So z squared is going to equal b squared plus h squared, but h is this 240 square inches over b. So that hypotenuse squared is equal to this value. Now I'm going to square root it, and I'm going to plop it right up here. So that's equivalent to the square root of, this is the z value, b squared plus, and I'm actually going to square this out, and when I do that I get 57,600. The inches actually become to the fourth power, and then I square the bottom as well. So when I square this fraction, this number becomes 57,600 inches to the fourth over b squared, and there is my function in terms of just the base. So this will help me find the perimeter given any base. If I wanted this base to be 3 inches long, I can plug 3 inches in here, boom, 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 and that function, once I analyze it, will end up telling me what the perimeter is. All right, so you can look that over again, and then you'll be ready to start on your own problems to practice, practicing 1 through 5.